Hello everyone, this is Kapil Jadhav and let's start with the Oracle GoldenGate webinar. So we are having 7-point agenda. First point is business driver, access to real-time data. Second point is history of Oracle GoldenGate and overview. Third one is Oracle GoldenGate case studies. Fourth one is Oracle GoldenGate technical details and how it basically works. Fifth one is replication topologies. Sixth one is Oracle GoldenGate tools. And last one is question answer session. So let's start with the first point, business driver and access to real-time data. So we need information right now or whenever we want. So do we really need real-time access? So this real-time access of data is possible with the help of Oracle GoldenGate. Oracle GoldenGate delivers real-time access of data, enabling companies to dramatically improve the ability, reliability, and performance of critical data across enterprise systems. So in various companies currently in the world, they are using GoldenGates. For example, S Bank, 90% reduced recovery time for mission critical transaction application. State Bank of India, they are having world's busiest ATM network, remains continuously available. Swedbank, processing more than 1 billion transactions each year and zero outages. Montefiore, 100% paperless environment drives efficiency and improves patient care across hospital. HCN, 100% availability during phased upgrade for 24/7 critical CRM application. AMD company, they are having productivity gains in manufacturing plant with real-time data. So all these companies, they have implemented GoldenGate and they need return from their investment. Then history of Oracle GoldenGate. So Oracle acquired GoldenGate in 2009 as part of future strategy to implement advanced replication technologies. Since Oracle Open World 2010, Oracle is heavily pushing GoldenGate as a strategic product in its portfolio. Before the advent of Oracle, GoldenGate data replication was performed using triggers, materialized views, and Oracle streams. And there were third-party applications like Quest Shareplex. So triggers. So I have seen many companies using triggers for data replication. I'll give you one example. For example, there are 4 sugar factories located near the central data storage. So data from these 4 different factories will be stored in the central storage with the help of triggers. So triggers, they can be used for replicating data from multiple destinations to the central part or the central storage. So this is one of the example of trigger. So trigger, it is for each row and it is before insert or update on this table employees, which is part of HR schema, and it is gonna triggered if the event it has occurred on this table employees, which is part of HR schema. So triggers, they can be used for replication of data from one site to the another site. Then even you can use materialized views for accessing data of another database. using materialize views. Okay, so this is the command to create materialize views. As you can see here, first you need to create database link between the two different databases using the connection string, and you need to connect to remote user, and that command is specified here. Then you can create materialize view using these two commands which are mentioned here. Then the third technology that you can use is Oracle Streams. So Oracle Streams can be used to share data between two different databases. So it is one of the tool provided by Oracle for replicating data between two different databases, and there is a one pool inside system global area of Oracle database, and that is streams pool size. So that can be configured if you want to configure Oracle Streams. So in triggers, programming is involved. If you want to use triggers, you need to do programming, a lot of programming. Then generates heavy performance bottlenecks on source database if you are using triggers. Then Oracle Streams can be configured, but it requires complex customization, and only Oracle to Oracle replication is possible with the help of Oracle Streams. So where Oracle GoldenGate can be used. So if you want to do a real-time CDC, or you are having log-based databases, log means transaction logs. For example, in Oracle, you are having redo-log groups to capture the changes of database. Then you are having heterogeneous systems, means you are having source database and target database. Then you want to have low performance impact, then also you can use GoldenGate. Then GoldenGate is very easy to implement, so it is having faster deployment, and it is not that much complex, so it is very less complex. So heterogeneous systems can be used for Oracle GoldenGate. You don't need to have Oracle at the primary site, and at the DR site you don't need to have Oracle. You can have the another technology. We'll see later on the various source and target databases supports. So Oracle GoldenGate can be used from the disaster recovery and data protection point of view. It can be implemented there with the help of DataGuard, and zero downtime migration and upgrades are possible even if you are using Oracle GoldenGate. Even if your database is configured for operational reporting, and reports can be generated if you are having Oracle GoldenGate implemented. So Oracle GoldenGate is a best tool. So let's see Oracle GoldenGate case studies. So Oracle GoldenGate, it facilitates zero downtime migration and upgrade. So let's see business challenges those are having for the companies. For example, RIM BlackBerry, they are having very small monthly window to take downtime for upgrades, migration, and planned maintenance. They are having strict SLA limits. So GoldenGate, it provides best solution for such kind of companies. So GoldenGate, it provides zero downtime upgrade and OS change for business critical Oracle database. There is one more product of Oracle GoldenGate, that is GoldenGate Veridata. It ensures that your production, the main site and your TR site of GoldenGate, they are in sync with each other, and the migration of data is successful. Then GoldenGate benefits. GoldenGate is having failback capability to reduce business risk and downtime. No manual intervention to reduce possibility of errors, and it assures data consistency between two different databases. So you can see here is an example of ADP company. Real-time data integration to support reporting demands. So business challenges, common real-time reporting functionality across ADP product suites, and ability to do cross-product reporting, incremental revenue opportunity, and improved customer service. And reporting gets moved off from production database. So GoldenGate, they have provided a big solution here. So live reporting for real-time data consolidation from 40 plus source systems into a centralized target. So you can see various database softwares like SQL Server is here. Then multiple databases of Oracle software are here, and they have been plugged into one database or the centralized storage where all the data is been consolidated with the help of GoldenGate. So GoldenGate provides minimal footprint and data latency, and GoldenGate maintains data integrity, and it supports data transformation and data security. So ADP company, they have implemented it. Then technical details and how basically GoldenGate works. GoldenGate is a part of Oracle Fusion middleware family, and it consisting of three subproducts. First one is Oracle GoldenGate, second one is GoldenGate Director, and last one is Veridata. So this is basic architecture of Oracle GoldenGate. So you can see here there are two databases. One is the source database and second one is the target database. Okay, and then there are two important processes. Those are running at the source as well as target side. So that is a manager. So Oracle GoldenGate Manager manages everything. So at both these sides, source as well as target, you'll be having Oracle GoldenGate Manager who will be managing all the processes related to Oracle GoldenGate. So for capture, there is a process called as extract process. Then all the changes, those are present on the source database. So all these changes, basically the committed changes, they will be captured by extract process. Then source trail, all the committed changes will be captured in the form of files at the source side. They are called as local trails. So these local trails will be captured at one destination at the source side. So they are called as source trail. And there is a one more process which is called as a data pump process. Basically it sends data to remote site and it captures changes from source trail. These are the files created for the transactions, committed transactions at the source site. Then you can see at the target site there is a process called collector. So collector process, it receives data from the primary site and it puts those data in the form of trails at a remote site, and they are called as remote trails. So at standby site or at target site, there is a one more process called as replicate process. Replicate process will capture changes from remote trail files and it will apply all these changes to target database. So let's go in detail of this architecture. So supported source databases for Oracle GoldenGate. So you can see here source databases, those support Oracle GoldenGate are C3, DB2 for Linux, Unix and Windows, DB2 for ZOS, MySQL, Oracle, SQL MX, SQL Server, Sybase and Teradata. So these are all log-based databases. So how basically the extract process it works. So extract is a operating system process that runs at the source side, and it captures the changes or the transactions, and these committed changes are extracted to a file. It is called as local trail or trail file. For example, in Oracle database, extract captures changes from redo logs, and for Microsoft SQL Server, extract captures changes from transaction log. So extract only captures committed changes, and uncommitted changes are rolled back. Both DML as well as DDL changes can be captured. So extract, you can configure multiple extract processes if required for better performance. Extract can be configured to capture single table, multiple tables, subset, or rows or columns. Even you can use discard file, records that capture cannot process. So extract process is the important process at the source site. So what is the importance of source trail file or the local trail? So extract process writes committed transactions to a staging file, and that is called as source trail. Data that is returned to trail is queued for distribution to the target database or another destination to be processed by another GoldenGate process such as data pump. Okay, so there is a two levels of or two types of transfer of data. Either you can transfer using the extract process directly to target database, or even you can use combination of extract process and data pump process to transfer data from source to destination. So data in the trail files can also be encrypted. You can decide the size of source trail file. For example, you have specified it to 1 MB. So 1 MB of data will be captured in that trail file, and when it will exceed 1 MB size, the next trail file will be created at the location. Data in the trail files is stored in in platform independent form. Trail file, they contain header, and the records those are present in the trail files, they are also having the headers. So trail file is having a big importance in Oracle GoldenGate. So there is one more concept called as CSN number or commit sequence number. It is quite different than the checkpoint of Oracle. The concept is quite different. GoldenGate uses CSN number to identify and keep track of transactions, to maintain the integrity between the source database and the target database. CSN is a GoldenGate platform independent representation of unique serial numbers that each DBMS uses to track the transactions it has processed. Basically, the CSN number is equal to SCN number. SCN number is a system change number, and CSN is called as commit sequence number. For MS SQL Server, CSN is equal to concatenation of virtual log file number, a segment number within virtual log, and the entry number. So CSN number, it plays a big role. Then there is one more process called as a data pump process. It has nothing to do with the EXPDP and IMPDP. So data pump process is one more process which works with the extract process. As we had seen that extract process will capture the committed transactions into local trails, and then data pump process will capture these changes which have been put inside the local trails by extract process, and it will transfer these changes to a remote site or a remote database. Okay, So data pump process, it reads records in the source trail written by local extract, and it will pass them through TCP/IP network to the target. And at the remote side, they will be captured by the another process, and they will be put inside remote trail. So at the source side there will be local trail, and at the remote side there will be remote trail. So data pump can be configured for data filtering and transformation, just like local extract. You are having two choices, either to use extract without using data pump, or the combination of extract plus data pump process. In many cases, the data pump reads the records in the source trail and simply passes all them to the destination. In GoldenGate terminology, this is called as pass-through mode. So as it is, data will be passed. So GoldenGate can be designed to run without a data pump. There is a risk if network goes down. So in that case, there will be a risk. So you can configure multiple data pump processes for increasing the performance, and even you can use discard file to handle the errors. So this is the use of local extract process without using the data pump process. You can see here you are having manager processes running at the primary and this primary site and the target site. So manager must be running at these both locations. So local extract is going to capture the committed data from read log groups of source database, and through network it will transfer all these changes to target database. So at the target site there is one more process called as collector process, which will capture all these changes, and all these changes will be put inside the remote trail, and replicate process will apply all these changes to target database. So here is a 1-to-1 ratio. For every extract there will be only one replicate. So if you want to configure one more extract, you have to configure one more replicate for that extract process. So this transmission of data is without using data pump. This is the transmission of data using the extract process. So here if you want to use the data pump process along with the extract process, means this architecture of GoldenGate is with extract plus data pump process. So as we had discussed earlier, the extract process is going to capture the committed changes of source database in the source trail or local trail. Data pump process will capture these changes which are present in the source trail files or local trail files, and the changes will be transmitted through network to the remote site. So collector process is going to capture the changes, and collector process will put all these changes or the local trails to the remote trail location, and data pump process will apply all these changes to the destination database or the target database. So network, so what kind of network you will need? So source trail files are sent over a TCP/IP network to remote host to generate remote trail files. The local or data pump extract communicates with. During transmission from source to target, you can compress the data to reduce bandwidth. So this is possible. You can compress data. You can tune the TCP/IP socket buffer size and connection timeout parameters for the best performance across the network. Even you can encrypt the GoldenGate data sent across the network from source, and it will be automatically decrypted on the target site. So encryption and decryption, this automatic encryption and decryption is possible here. So collector process, it is the important process at the target site. It runs in the background on the target site, and it records or receives the remote trails. The records, those are sent across from the extract process or the data pump process, are captured here, and they will be captured by collector process at the target site. So remote trail files, what is the importance of remote trail file? Remote trail files are created on remote server, which could be the target database server or some other middle tier server. So there is one directory when you will install Oracle GoldenGate software. The directories are created. So out of that, there is one directory with the name dir dat. So at the source side as well as at the target side, all the trail files, means source trail, those are called as local trails, and remote trails, those are called as remote trails. They are captured inside dir dat directory. So how these local trail files or remote trail files will be created? So if it is a remote trail file, it will start with 2-character prefix as RT, and there will be a 6-digit sequence number after that. And if it is local trail, it will start with the prefix LT, and then 6-digit sequence number will be followed. So just like source trail, data in the remote trail file is stored, it is platform independent. So it is GoldenGate format. Each remote trail file, it contains the file header, and each record that is present in remote trail file is having its own header. Now if you want to read these trail files, you are having log dump utility provided by GoldenGate. So you can read these files. And remember, never edit or manually change these trail files. So there is one more process, and that process is replicate process, which needs to be configured at the target site. And replicate process, its basic work is to capture data from remote trails and apply all these changes, those are present in remote trail, to target database. You can configure multiple replicate processes. For each extract process, there will be one replicate process. So replication can be done on entire schema, or on single table, or on subset of rows, or on columns of a table. So it is possible. You can configure replicate process to map data from source to the target database. So this transformation is possible. So replicate process, it is capable of filtering data. So the target databases, those are supported by Oracle GoldenGate are C3, DB2 for iSeries, DB2 for Linux, Unix, Windows, DB2 for ZOS, generic ODBC, MySQL, Oracle, SQL MX, SQL Server, Sybase, and times 10. Then importance of manager process. Manager process, it always works or runs on the default port 7840. This is the default port for manager process. Manager processes, there will be single manager process at the source side, and there will be a single manager process at the target side. So all the other processes at the source as well as target site are managed by manager processes. So a single manager process runs on each server where GoldenGate is executing and processes commands from the GoldenGate software. So the way we are having SQL prompt to fire SQL queries, we are having rman prompt to fire rman backups commands. We are having ASM CMD prompt for ASM commands. Similarly, we are having GGSCI prompt for managing GoldenGate commands. So manager process is the first GoldenGate process that gets started at the both sides, source as well as target. So manager, it starts and stops other GoldenGate processes. It manages the trail files, it manages the log files and reports. So manager process must be running at the both sides. So how basically Oracle GoldenGate works? So you can see the source database, the changes, those will be captured in the trail files. So what kind of capture will be done? The committed transactions are captured, and they are captured from the transaction logs. and they will be put inside the trail files, and the pump, that is the data pump process, it is going to distribute data to the target site, whether you are having LAN, WAN, internet, and this is done with the help of a network, as we have seen in the previous slide, the TCP/IP network. Even you can configure GoldenGate for bidirectional transmission, means the source database will transfer data to target, and target even it will transfer data to source side. So this is possible. So the routing, it can be done in the form of encryption, and the data will be decrypted at the target site. So data which is captured in the trail files of remote site will be delivered to the target database. So GoldenGate, it maintains the transaction integrity, and transforming data is possible. So replication topologies, this is the fifth point. So replication, one-way replication is possible, where source database will send data to target database. Then bidirectional replication is also possible, means the source database will send data from source to target, and even target database will send data from target to the source. So this is called as bidirectional replication. Broadcast replication means from source database we are sending data to multiple destinations. So the target database, there will be a multiple target database. Then integration replication, there will be a multiple source database basis, and target database will be only one. So these are the replication topologies. So one-to-one replication or one-way replication, so one will be the active one and the target will be passive one, and the data changes from the source side will be captured here, and the use of one-to-one is for reporting purpose, query offloading, and the hot standby, that is for data guard. Then bidirectional topology, it can be used in the environment of active kind of data management. So data changes, they will be done at the source side and they will be replicated at the target side. So here the use cases, it is in the environment of high volume and high performance. So both the source as well as target, they will be changed in the bidirectional, means source will become target and target will become source. Means at a time you can have the bidirectional replication, means two-way replication, both will be active. Then broadcasting one to many, so that is possible. So one will be active and the other ones, the many ones, will be passive. So data changes will be at the source side only, and data distribution to multiple sites is possible in this topology. Then integrating many to one, so the active passive kind of network is this. So data changes, they will be at the source side, and it is basically used in the data warehousing kind of environment. Then GoldenGate, it facilitates zero downtime upgradation. You can see this bidirectional topology. So see the first one, the local extract, it is going to capture data to the source trail. Then data pump process will transfer these changes to the remote side through the network. Then they will be captured in the remote trail, and replicate process will apply these changes to target database. Now the target database, it is going to act as a source database, and the source trails, those will be captured in the source trail, and through data pump process you can transfer the changes to remote trail, which is present at the primary site, now which will be considered as a target site here for this bidirectional transfer, and replicate is going to apply the changes to the target site. Now GoldenGate tools and utilities. So there are various tools and utilities of GoldenGate. One is GGSCI. Its long form is written here, GoldenGate Software Command Interface. Then DevGen utility is here. Then log dump utility and reverse. It is one more tool. Director, GoldenGate Director is one more tool. So GGSCI is the command prompt. This is called as GoldenGate command prompt. You can manage all background processes, extract, replicates, then manager process, and even you can manage the local trails and remote trails using GoldenGate. So there are a number of GoldenGate commands. Even you can use help command to see the information regarding GGSI, the commands and their syntaxes. So you can see the how to manage the manager process. So edit params mgr. So you can see here the default port of manager is 7840. Info manager command is gonna display info regarding the manager. Then to start manager there is a command start manager. Then there you can see here one extract process is been configured, edit params lhr emd1. So this is extract process, and the information is present in this extract process, like the environmental variables. They have been set NLS language, which is American, which has been put here. Then there is a GoldenGate user, uh, which is written here, and its password is put inside this extract process. Then we have seen this DevGen utility or DevGen tool provided by GoldenGate. It is present in the GoldenGate software itself. You can read the data pump extract process, and it will generate a data definition file for each data pump extract process. And DevGen, it is part of regular GoldenGate installation software, and it is available with the GoldenGate software. Then log dump is a one more utility or the product provided by GoldenGate. So this utility views records, those are present in the trail files. So we have seen two types of trail files, local trail and remote trail. So these trail files can be managed using log dump utility. So log dump utility is part of the GoldenGate software itself. It's a product of GoldenGate itself. So log dump let you view the unstructured trail data in hexadecimal and ASCII format, and it can count the number of records in the trail for debugging purposes. Even you can also filter the trail for desired records and save them to a new trail for reprocessing if needed. So log dump utility, it will manage the trail files. So these are the various tools available with the GoldenGate software. There is one more product or utility provided by GoldenGate. It is reverse. If you want to undo database changes, then you can configure the reverse utility. So reverse utility is going to use one special extract process, and it is going to capture the before image of changes, and it will reverse the order of changes, and it will write a new trail file for doing the reversal. So even the reversal is possible, but you need to configure reverse utility. And replicating these changes to a reverse trail to undo database changes. Reverse can be useful for backing out unwanted changes to the database, or quickly restoring a test database back to its original state, to its old state. So this is one more utility provided by GoldenGate. There is one more utility called as GoldenGate Director. It's a graphical tool, the way we are having Oracle Enterprise Manager to manage the entire Oracle database. Similarly, we are having Oracle GoldenGate Director utility to manage entire GoldenGate environment. So you can manage GoldenGate using graphical tool, and that tool is GoldenGate Director. So GoldenGate Director is a multi-tiered GUI application used for monitoring all GoldenGate processes. So you can see this graphical view of Oracle GoldenGate web page. So you can see the information regarding extract processes. It is present here. So you can manage GoldenGate using GoldenGate director. So this was all about the GoldenGate architecture. So any questions, they are welcome. So first question is regarding the Oracle extract process. Uh, Guys, you are having two kinds of capture of data. Means there are two kinds of processes. Those are running at the source side. One is extract process, and second one is the data pump process. So either you can transmit data to the target side using extract process, or second type is combination of extract and data pump process. But if you are using only extract process for transferring data to the remote side or at the target side, if in case the network failure it occurs, so at that time data transmission may get failed. So but if you are using extract process with the data pump process, so the changes at the source side will be captured in the form of local trails in the dir or dat directory of Oracle GoldenGate, and the changes from the changes those are captured in the local trails are further transferred by data pump process, which is at the source side, to the remote side or the target side. Now how to manage is Oracle GoldenGate errors. So there is a one file, GGS error log, GoldenGate error log file. In that file you can manage the, or you can check the errors related to Oracle GoldenGate. Okay, so next question is regarding the collector process. Collector process, this process will not be present at the source side. This process will be always present at the target side, and collector process will work with the data pump process. So the data which has been sent by the data pump process of source database will be captured by the collector process, and collector process will put the remote trails inside dir dat directory of target database. So collector process will always will be working with the data pump process. Next question is regarding the GoldenGate checkpoint. So GoldenGate checkpoint is quite different than the Oracle checkpoint. This checkpoint, Oracle checkpoint, is quite different than the Oracle GoldenGate checkpoint, because there is a concept of checkpoint table. So as a DBA, you are going to create checkpoint table at the target site, and after creating this checkpoint table, for example replicate, it has replicated or applied two trail files to the target database, and while applying third trail file, the database crashed. Okay, so this information of two trail files which are being applied to target database means their CSN number will be put inside the checkpoint table. Okay, and the checkpoint table will be later on checked while restoring the other third trail file. So replicate process will check that the only two trail files have been applied to target database and third one is not applied. So this replication or the recovery of third trail file will be done with the help of the checkpoint table. So checkpoint table will store information of checkpoints, means each committed record will be having one unique CSN number, and that CSN number will be used for replicating data to trail files. So thank you. This was all about Oracle GoldenGate.